Hey guys, it's BlockchainBrad, and today I'm very honored to speak with two very important gentlemen before me. They are representatives of an exciting blockchain called OneLedger. To do this and to discuss it further, we have David Cow and Matt Niemerg. Both of you, thank you so much for being on the channel today.
Thanks for having us, Brad.
Not a problem.
Thank you. Nice to meet you here, Brad.
So just some background knowledge on David firstly, and I'm sure you can imagine who I'm talking about. David is the CEO of OneLedger. He's done some quite amazing things in the recent past in blockchain, that I guess since its evolutions and iterations. He has more than 10 years experience in enterprise architecture experience. He also has worked for a number of technical projects, including Fortune 500 companies, and the list goes on. So David, without further ado, could you tell us a bit about yourself, mate, and what really brought you to OneLedger?
Okay, so I'm going to give you some brief introduction about myself. After coming to Canada, I spent a few years working at IBM. I working on DB2 and work on the WebSphere commerce. And in 2008, I created my own consulting company, work for the enterprise solution, work for government, work for bank, and a big retailer. So I work on multiple enterprise projects. It's a budget scale from 4 million to over 10 millions. So after I work on a few years on the enterprise application, about 2-3 years ago, I get into the blockchain area. So after I involved into blockchain, I love this technology a lot. I think the decentralized application is going to be the future of the human being. So I did the Hyperledger project and also involved into the Ethereum project. After I went through this few blockchain projects, I find some kind of the limitation on the blockchain area. So in the different country and people like the different blockchain. They build the business usage and apps on the different chain, but this blockchain it stay in a different country. It's kind of isolated, so there is no way to communicate between the blockchains.
Right.
And also the people try to build the similar thing like a social network. It's a similar functionality on the different blockchain, and in this way it's kind of the duplication. So that's why it come out of the idea of the OneLedger.
Right, and we're going to be talking about that more in depth, the idea and the solutions to a problem that no doubt you thought of. But if we could move across now to Matt Niemerg. Matt, it's a privilege to have you. You are the DLT specialist. You're the technical advisor for OneLedger. That's a significant role. But no doubt before that you did a number of things to get to this point.
Yeah, so I started out, I got my PhD in mathematics from Colorado State University back in 2014. And then after that, I did a postdoc at the Simons Institute in Berkeley. So I was a Simons Berkeley Fellow, and that was a joint position that I had at UC Berkeley and then with Tsinghua University out in Beijing. And then after that, I went ahead and I was at UT Toronto for another semester. And then finally, I ended up at IBM doing a postdoc at the Center of Excellence on high-performance computing. And just recently, back in November, I left IBM to pursue distributed ledger technologies full-time.
Okay, so that's quite impressive, I have to say. And if you don't mind me saying, you look like a rock star as well. So you don't see that in the space quite often. I speak with many people, with your credentials, and you've done an amazing thing already. Considering your background academically.
Oh, thank you.
So
just add one more, just add one more comment here. And so Matthew is the OneLedger technical advisor. And he is not just only the advisor, he is really like the part of the team. So he involved in the OneLedger in the early stage, and we have a lot of discussion regarding how we are going to build a OneLedger platform. Yeah, and he also have a very deep understanding about the OneLedger too.
Well, Matt, no doubt the OneLedger team is very excited to have you on board. You clearly are well experienced in this space and you're going to be an asset to the team. Let's get into the crux of why we're here, though, gentlemen, and that is to talk about OneLedger, the fundamentals. But to do that, perhaps the best thing to do is to find out what the reasons are for your existence. What were the problems that you felt, David, that needed to be addressed? You mentioned them, I guess during your discussion in the beginning about yourself. What was the thing that led you to make OneLedger happen?
So I think the main limitation and the problem on the blockchain area, first thing is interoperability. So the people try to running the transaction across the different chain. It based on the consensus. So in this way, I think a lot of projects are working on this area too. And also the other way is how we bring the blockchain into the enterprise level. So on the enterprise level, which is usually on the public chain, people running the public transaction, it's the permissionless. But for enterprise, in order to have this kind of access control, so the enterprise try to pick up the private blockchain. But with private blockchain, so they have nowhere to run the public transaction, so they have nowhere to access the public wallet from the personal identity.
Right.
So that's why from the OneLedger, on the top, it try to bridge of the permission the transaction and the permissionless transaction, so that you can build a real solution for the enterprise and also for personal usage. So on the top of the OneLedger, it's kind of like the mapping of the society with the personal functionality plus the social functionality. Right. It could be with the access control.
I see.
Then with this kind of a universal of the top level, the business usage, on the bottom, then OneLedger is support the cross ledger and cross the chain transaction. And in this way, so all the business usage on the top of the OneLedger, it have a more scalability and more the custom usage in the future.
I see. So David, thank you so much for that explanation. And Matt, if we could move across to you now, mate, just with regard to the technicals, that's your background. One of the key aspects of your design is making sure that you incorporate permissioned and permissionless architectures and more importantly protocols. So what essentially are these, and why is there an imperative to incorporate permissioned blockchains into your architecture?
Yeah, no, that's a great question. So really, let's maybe start off with what are permission schemes versus permissionless schemes. So permissionless schemes were introduced with Nakamoto consensus. And what is this? This is allowing people to enter and leave the validation, sort of the validate, being a part of the validating network at will. And with a permission scheme, you don't obtain that, right? You actually have the validators are known ahead of time. They're known a priori. And so what you have in a permission scheme, you gain in a lot of ways. One of the ways that you're gaining is in scalability, because you know the validators ahead of time. What this allows you to do is to code, right away a certain optimization. So if you know that you're going to have 127 validators, and that's how many validators you're going to have on your network, you can actually write your code so that, okay, I know precisely these are my validators, and I can go ahead and specify their IP addresses, and that could all be hard-coded in. And so now you're really able to gain on certain types of optimizations. Whenever you have this arbitrary entering and leaving, you don't know a priori who are going to be the validators. And so since this set of validators is constantly changing, you have this different bottleneck that is going to slow down the number of transactions. I
see. So essentially we're talking about certainty versus uncertainty, and the permission aspect provides that certainty for, as you said, a priori, for design, for nodes, for building out, and most importantly for scalability. But in that sense, there's also the public ledger, there's also the permissionless design that's imperative. Why is that so important?
Well, just as we were talking about, is that in general, by having an open network, then you're able to allow for this arbitrary entry and sort of leaving. So what this allows you to do is to sort of build and have this network effect and this growth. And so now you're able to allow for people to join a decentralized network. And so their value, they can contribute to this project in a lot of ways, either through the open source development community, or by running infrastructure nodes, or any number of things.
I see. Well, thank you for that technical analysis of those two. Now let's sort of meld them together with what you stand for, because you're doing something quite unique. On the internet explains that you are the universal blockchain protocol, and extending on that, you're also going to enable cross-ledger access through business modularization, and we're going to explore those things in detail independently. But let's start now with your cross-ledger access component, because that's the perfect segue from what Matt was saying, David, with regard to the permission and the permissionlessness. But you're going to do something more than that. So can you tell us a bit specifically on the cross-ledger plan?
Okay, yeah. So on the top of the measure talking about the permission and the permissionless transaction, I can give some like the high-level example. So which is like the OneLedger is trying to create the business usage on the top of the personal identity. It's like the social or the business functionality of the society. If you use your own wallet or if you do your public transaction, you can just be your own personal identity to anything. But if you want to do some of the business or you go to work, you may need some of the access control to allow you to do these kind of things. That's why on the OneLedger, we try to bridge the permission list and the permission the transaction so that it can map to a real business usage and also give the scalability to the personal identity.
I see. So you're bridging essentially key blockchain protocols and architectures together through your design, and more specifically, you're bringing blockchains together. So Matt, can you tell us a bit about that in terms of complexity and what specific blockchains you're hoping to bridge?
Right. So really the core protocol that's being used is this ability of having hash time lock contracts. So a hash time lock contract is nothing more than sending a transaction and then imposing for example, in the Bitcoin script operations, there's a way of saying, I don't want you to be able to send this transaction except for after block number X. And once block number X is reached, then you have the ability of sending that unspent transaction output. And so with this and with the use of payment channels, there's certain cross-atomic chain algorithms that allow you to do interoperability and sort of chain swaps. So the idea that we want to be able to do is to have somebody go ahead and spend a transaction to a hash time lock contract. That hash time lock contract is in an address that they control. That address has a particular private key, and that private key is actually going to be the same private key that's used in their OneLedger account. Okay. And now what's going to end up happening is that OneLedger will be able to recognize that there's this transaction on, say, the Ethereum, main chain, and see that there is this, a transaction to this particular account. We'll be able to load up on the OneLedger wallet and go ahead and say, all right, well, now you've credited this amount to your OneLedger wallet on the OneLedger Ethereum sidechain, and now you can go ahead and if I send to my Ethereum account and it's in a hash time lock contract, I can go ahead and send this some Ethereum to Alice. Alice can send it off to Bob and to Charlie, and then it goes all the way down to Zeke at the end of the day. And Zeke says, all right, well, I want to go ahead and move it back to the main Ethereum chain. And so what's going to happen is that through the use of the hash time lock contracts and some payment channels, Zeke is going to be able to spend that hash time lock contract and go ahead and move it off to the main, quote unquote, to the main chain. And so what's happening now is that all those transactions that are occurring are still going to be essentially going to have a consensus occur on the OneLedger main chain, or rather the OneLedger side chain that is associated to the Ethereum main chain. And so now what you end up having is, in addition to this sort of offloading of transactions now to OneLedger, you're also able to sort of go ahead and make use of the probability one consensus protocol that we have.
I see. And David, if it's okay,
yep.
What an excellent segue into discussing the sidechains, because Matt's already broached it. Yep. Obviously, the sidechains are a key part of your architecture in the way in which you're trying to build out the overall robustness of your design. So can you tell us a bit about why you've chosen this methodology of utilizing sidechains, and more importantly, can we talk about that in the context of the blockchains you've already considered in interoperating with?
Okay, so that's a very good question. So before I talk about the sidechain, so I want to talk about the few key features of the OneLedger. So first of all, is the OneLedger, which is we're using the business modularization. Mm-hmm. So what's the business modularization? So think about so when you write a smart contract or when you write any of the blockchain application, we still need to starting from the coding level. We need to write the code line by line. But the modularization, it gives the developer a bigger flexibility to build the code and deploy code easier than before.
Right.
So modularization, we will map the business functionality into a module. Then in a module, we have a definition file. We have an object. Through that object, through definition, we can treat the code logic. So in this part is a very structured coding for the developer to working on. And after the people define this the module on the OneLedger level, so this module and also definition and also the object file could be converted into the master smart contract, which is running on the OneLedger level to driven the multiple transaction, include the in-chain or include the cross-chain.
I see, and I think if we could just stop there for one moment, and I'll move across to Matt, and we'll go back to you, David. Don't worry, Matt. Could you tell us a bit more about specifically that master smart contract design, because that really is something setting you apart?
Yeah, so the general notion is that it could be the case that if you have a smart contract for, say, Tezos versus a smart contract for Ethereum, you're going to have the Michelson language versus the Solidity. And so now you have to, if you're a developer, you have to actually go ahead and develop in both. So what we want to be able to do is have this master smart contract that's within the OneLedger protocol. And what that will do is identify the corresponding contracts in either of those two languages. And so now what we can do is allow for deployment of the contracts to actually occur simultaneously on both the Tezos and the Ethereum chain.
I see. So David, thank you for starting off this conversation, and we're going to now discuss the sidechains as part of it. But could we do that also in the context of dApps, because that's obviously the premise. With smart contracts comes applications and purpose. So sidechains and dApps, could we talk about that?
Okay. So regarding the sidechain, so how we understand the sidechain. And because from the OneLedger, we try to offer the universal protocol on the OneLedger level to driven the transaction from the OneLedger sidechain into the public chain. Mm-hmm. So this like a driver. Through this driver, we can always to be synchronized and parallel running transaction with the public chain together. And the other way is sidechain, because from the sidechain of the OneLedger, anytime you can call the public transaction from the main chain, and you can always to offload the transaction or the traffic. Mm-hmm. So you can always offload the transaction and the traffic from the main chain or public chain into the side chain of the OneLedger level to have the high performance of the transaction.
I see. So essentially you're trying to make the blockchain more performant by branching it into these, or splitting it into these multiple sidechain model. And we've seen that with other designs that are coming up right now. But let's talk about now, I guess, the reasoning, the purpose, and that is to bring in more applications, to bring in essentially business into your blockchain architecture. So in that respect, what specific blockchains are you currently talking with in terms of these mainstream ones we know of now?
Yeah. So regarding regarding main chain or public chain, we are going to be the compatible with. It could be the Ethereum, it could be the Bitcoin, or even could be the Hyperledger. So after we bridge this field main chain, so first of all is the existing application on this application that can migrate to the OneLedger level. With migration on the OneLedger level, and they're running the master smart contract, which is they can still keep the integration of the data as before, as they're running on the public chain. Meanwhile, they have ability to driven the transaction from the OneLedger. Meanwhile, they can always using the master contract from OneLedger to driven the transaction across the multiple different chains. Meanwhile, they can also maintain the integration of the data and with the public chain together. I
see. So Matt, if you could just extend this a bit more, just so to clarify, we've seen many platforms exist, specifically more the dApp platform. Ethereum is a great example where we've seen an innumerate number of them onboard onto their design. But you're essentially not going to be doing that, is that right? You're more about being a hub to enable the bridging and the interoperation of all these different dApps that could function on these separate verticals.
Yeah, I think that's a much better way of understanding what OneLedger is offering here. And what you can think about is anytime somebody wants to launch a dApp or essentially with Ethereum, right? What is an Ethereum dApp? It's really a smart contract is still an Ethereum account. And then there's some Solidity code that is governing how this smart contract operates. So it's still, you have this entire state associated with the smart contract.
Right.
And then all you're doing now is updating the state with the consensus model. So if instead you're saying, all right, well, if all I have is state changes and I have some smart contract code that is governing how the state change can occur, well, you can go ahead and have that be done, not necessarily using Solidity. You could have that being done on OneLedger by launching your own permission sidechain that could control your particular dApp.
Right, and that makes perfect sense.
Yeah. So here I can give some good example, which it could be running on the OneLedger in future. So first of all, since on OneLedger level on the bottom, we're using the universal cross-chain protocol to synchronize and coordination transaction between the different chain. So once we have this protocol, it's become the very good usage is the decentralized exchange.
Mm-hmm.
The decentralized cross-chain exchange, actually.
I see.
So it will be supported by the OneLedger, this cross-chain protocol.
I see.
Then on the top level, before those isolated application on a different blockchain, they can be unified. So when we say unified, I give you examples. For example, before the car manufacturer, they build the car, and it's the blockchain. It's an application on one of the blockchain.
Mm-hmm.
And the car dealer selling network that sell the car is running another blockchain with the application.
Right.
And also when people go to registration, the government pay for some of the private chain. Then they build this registration application on maybe the Hyperledger or the other private the blockchain.
Right.
And in this way, the people go to the different chain, they're using a different identity. Between these different chain, even if a car is the same digital asset, they have nowhere to be running on the same digital asset going through the different the blockchain application. Mm-hmm. So, but once we migrate this different application into the OneLedger level, so it will become the module of the OneLedger. So people use the universal same identity. And this identity, they can become the employee of the car manufacturer to build a car. Right. So after build a car, the same car asset go to the dealer network. When this guy employee want to buy a car, they can use his own personal identity to join the dealer sales network to buy a car as part of the participant. So then if this car is the same digital asset, this car asset, it go into the registration process. Then the same guy is go to the registration. They still can use his identity, which is on the OneLedger, to go in through the registration process. And the same car asset is starting from manufacturer. That can be tracked and use this kind of the blockchain of the advantage to go through a different module. Starting from manufacturer and starting from dealer sale and until registration. It's the same digital asset flow.
I see. So you're solving the problem of having to do this multiple times in terms of registration of ID, in terms of, as we see now, exactly. Even it's just a one-stop shop. You do it in one place, and then you can apply it through many different processes and steps in the process. More to the point. But Matt, if we could talk now, as David was explaining about the functionality and the key steps, no doubt there's a key consensus protocol built into this. And what essentially, as I was listening to both of you, a great metaphor perhaps we could look at for what you stand for is being really a protocol glue. You are a protocol glue that's binding blockchains, it's bridging them together, bringing them in. You are essentially the glue of the web that we're seeing emerge now as a very functional enterprise entity and space for, in terms of blockchain. But to do that and to achieve it, you need a good consensus mechanism. So can you tell us a bit more about that? My understanding it's the bias and time fault tolerance system.
Yeah, so this is a PBFT, Practical Byzantine Fault Tolerance. Mm-hmm. So this is a paper from 1999 by Castro and Liskov. And what it is a leader-based design where the leader goes ahead and proposes an order on the transactions that have just recently occurred. And then what ends up happening is that the validators on the network over 2/3 of them will receive the proposal, and then if 2/3 of them, well, all of them receives the proposal. If over 2/3 of them agree that this proposal is valid, they'll submit their pre-vote and say, yes, I've got this. I think this is a valid proposal. And then once that gets submitted off to everybody and broadcast to the rest of the validators will once again approve the validation or the validated vote of the previous round, and go ahead and once that has 2/3, you'll get that appended now to the get an approval and get that appended to the state change of the database.
I see. So essentially, it's really trying to automate consensus, trying to make it really smooth with the most democratic approach you can.
Well, this is an algorithm that's been around in the distributed computing world now for, well, since it's 1999, so we're looking at 19 years.
Right.
And so there's it's sort of had some tried and trueness is used quite often, but what we're really doing here is doing a modified version of this to make it into a permissionless scheme, and then also using the original version as a permission scheme. Okay. And so the idea is that you can take a lot of these. There's a lot of analysis that's come out in the recent years in the academia worlds. There's the sleepy consensus models. I'm not going to bore you with all the details, but what ends up happening is that you get this committee, and this committee is keeping track of basically some consensus on who the committee is and how much they can all vote on and everything like that. And there's a way of, if you keep track of this from state change to state change, then anybody who can enter into this new permissionless setting can actually know without actually going through, can actually go ahead and be able to validate, the next state change. Right. And so that's really what's happening, is that you have this modified permission scheme that's been transformed into this permissionless setting, and what's being done is the underlying level is this practical Byzantine fault tolerant.
Right, and I'm so glad that you mentioned that this is happening now. I just wanted to talk to you more about that, Matt, because obviously some of the competitors, or perhaps just other entrants into the space, more to the point, are utilizing the same BFT, and they're doing it in different and variant ways. And one of them is the asynchronous model. One other one is the semi-synchronous model. So can we talk about that now in terms of synchronicity and why you've chosen not to do that?
Maybe David can go ahead.
Okay. Yeah, so I think before we jump this part, and I want to talk about a little bit regarding our three-layer consensus.
Yep.
So basically, on the top of the BFT, we have the three-layer consensus, which is the raw consensus, and the sidechain consensus, and also the public chain consensus. So you can think about it from top to down, and with the performance is with the raw consensus have the high performance, and the public consensus it have the least of the performance, but it has a high consensus. It have a list of the performance, but have a high consensus level.
Yes.
So you can think about the raw is kind of a partial consensus. So partial consensus, which means you can only assign the few node to running this transaction to have the consensus, but with a better performance. So when the block being written into this few node, then how we reference the network each other, then it means we always need to have like the few super node. We call it the witness node. Okay. So witness node based on it will join to all the transaction, and it also maintains the integrity of the data. So when we running the partial consensus and also the broadcast consensus together, then this kind of two category of the transaction on the OneLedger level. So we through the Merkle Tree, then to make the reference between this the partial consensus and the broadcast consensus, and this data and this block can be referenced to hash each other through a Merkle Tree structure.
I see, and there's also some great diagrams that explain those three different tiers, or more importantly, those three layers of consensus. If you'd like to see them, I'll certainly post them for you, and there'll be links below. Yeah. And Matt, if we could now...
Also, yeah. So, and the plus this, below the raw consensus, we also have something called a sidechain consensus. Okay. Sidechain consensus is, we always have this parallel running the sidechain with mentioned together. So anytime if people want to have the better performance, they can always offload the traffic from the public chain into the side chain, and using the OneLedger sidechain consensus to reach the better performance. But meanwhile, it always can be the synchronized and the communication is mentioned together with the sidechain consensus.
And David, just on that note, can we talk about numbers in terms of TPS? Because that's something that's thrown out, to the public in almost every blockchain presentation.
Yeah, that's right.
But let's get real with that, because there's some crazy numbers that get thrown out.
Yeah, so when we're talking about the TPS on the OneLedger, so the speed and the performance on the OneLedger is really elastic. It depends on how you define a role, and it depends on how you define a role to join the transaction. Mm-hmm. Then in this way, you can define the public consensus or the partially consensus. And in this way, you have the balance between the consensus and the performance. And also, this result will be use a reference hash to reference through the Merkle Tree.
I see.
So that's why you can even use the few node to running the transaction, really like the centralized system.
I see.
But because we use this the hash reference on the whole blockchain, so all this data, anytime it can be synchronized with the whole network together.
I say, so in terms of numbers, Matt, we'll address the previous question in a moment, but just in terms of numbers of TPS, and it being elastic, there's no specifics you can give with regard to capacity?
Yeah, I think that what you can think about, though, is that each sidechain itself is essentially running independently of another sidechain. And so, say for instance, you're doing a Dogecoin to Litecoin trade. Mm-hmm. There would be some type of there is an inter-sidechain protocol that allows for those two transactions to occur. Well, as David mentioned, there's a reference hash to so if it's a Litecoin to Dogecoin, then that transaction will reference back to both the Litecoin and Dogecoin sidechains on OneLedger within that one transaction that occurred for those two trades. And so what you have, though, is for the most part near independence of just, okay, well, if I'm just going to go ahead and move Ethereum around on the one side chain, or if I'm only going to be moving Bitcoin around, these you're able to sort of stack these up on top of one another. But as far as hard numbers, like David was saying, because you have this you're setting the permission scheme, because you have a permissionless scheme where you have an arbitrary number of validators. This is going to be completely dependent on the number of people participating in the network. I see, and so naturally that's going to evolve in time as this architecture becomes more of a utility. Yeah. Awesome. That's right. If we could talk about now the asynchronous, I did want to ask you that because we see some cutting-edge blockchain architectures coming forth. I'm sure you know of them, and they're doing something a little different with their BFT. Yeah, so asynchronicity, this is it's difficult to design a fault-tolerant system that is able to achieve asynchronous design, mainly because you have the FLP theorem. So this is a theorem. I think it's Fisherman, Lynch, and Patterson. Or Fisher, Lynch, and Patterson. We'll take your word for it. Yeah, I don't remember off the top of my head, but I think what they were able to show was that if you have an asynchronous network where messages can be delayed, and delay depends on how long the delay occurs. There is no consensus algorithm that can guarantee that it can terminate. And so what ends up happening is that there are ways around this, but you have to actually design this in a lot of ways. And so there's some fundamental issues with actually being able to achieve this. Now, obviously, like you say, most recently what's come out is you got Algorand, I think, which is I think came from the Bizcoin team. Yep. There is Thunderella from Shi and Pass. There is Hashgraph now from Liemonbaird, and so on and so forth. And so what you have, though, is a lot more I guess a lot more activity from the academia side, at least not just joining the blockchain space and the distributed ledger technology space. They've been around since, for the longest time.
Exactly.
But the issue is that you've always had this permission scheme. So now, with this move to a permissionless scheme, you have to be able to adapt and have this modification that allows for this. So really, you should be able to take any permission scheme and make it into a permissionless design using more or less one of three ways. You can do a proof of work mechanism similar to what Zilliqa does to become a part of the validating set of nodes. You can do a delegated proof of stake where now you're either a proof of stake, and I would say delegated proof of stake falls under that, where now you're the amount of stake that you have is going to give you some type of voting weight. And then also you would do maybe some type of collateralized masternode setup where that collateral is basically you being allowed to become a part of that formal validating set. Right. And so the idea would be that in between any two signed states, you're able to leave and enter the network, and you still have a little extra bottleneck that's going to occur in between any two signed states. But now, during that actual that next whenever you're trying to figure out, well, what is this next update to the database between these two signed states, you're essentially going to act as a permissioned network. Right. And so all you have to be able to do now is have some type of modifications enough to be able to obtain this permissionless arbitrary entering and arbitrary leaving.
And Matt, thank you for making that clear, because what you've really sort of brought to the fore is that the BBFT, regardless of sort of the angle that a blockchain entity takes, this is sort of the cutting edge when it comes to connecting the blockchain plan with enterprise.
Yeah, exactly. So since we're using that as enterprise solution and also the permission transaction with the role control, and the synchronized or the asynchronized really not the issue on the OneLedger level. Right. Because from with the permission network, we can really achieve the high performance and also make the balance between the public transaction and the partial transaction.
I see, and clearly not worried about any of the other entrants into the space utilizing something similar. But if we could talk about now your use cases, I really want to unpack that in the context of enterprise. So perhaps, David, you could talk about this a little bit more. In terms of business frame, imagine I'm a person considering utilizing this kind of cross-chain ledger technology. I have an enterprise, that I want to sort of build out in the blockchain. Why should I choose you?
Okay, so as I said, and with first of all, with the permission control, and the OneLedger can implement the high performance transaction. So I think this could be meet a lot of requirements from the enterprise level. Right. And the second thing is on the OneLedger, as we're talking about, we have the modularization. So modularization is we don't need to put a line code line by line. You can build an object. You can build a definition. Then you can build the high level of your business function. Then in this way, you can convert into the smart contract on the OneLedger level. So then in this way, it can bring the enterprise leverage much quicker than before to leverage the usage on the blockchain level.
I see. And Matt, did you want to add to that as well? Like, why would an enterprise, why is this such a strong enterprise solution in terms of real world use cases? I'm sure you even know of businesses utilizing the system already. So what's the carrot or the key carrots in terms of your features?
Yeah, I think that the main thing is that with this use of PKI, this public key infrastructure, if you're an enterprise and you have say maybe you're not even a technology company, right. And so now what are you going to do? How do you join this new technology space? You can go and potentially participate in Hyperledger, or you could participate in the Ethereum network, but this still requires you to obtain developers and to find people who can go ahead and write your smart contract code and all this. Not only that, if you're often what it'll do is you'll still need to have to run the infrastructure, the nodes that are doing the validation process. And so what OneLedger can provide, at least from that sense, is you can have multiple software developers that could go ahead and write their sort of smart contracts for a particular business module. And enterprises can come in, say somebody wrote a bunch of sort of a supply chain framework, and now somebody can come in and say, all right, well, I just need to keep track of maybe inventory control for my gas stations. I have 20 different gas stations in Illinois. I don't. My uncle does. Right. But maybe he has he wants to do inventory control, and he just wants to keep track of all the Coca-Cola that is coming into his out of his store. And the idea is that now you could actually go ahead and say, all right, well, I'm going to identify all the little pieces and products that are in the store, and well, I don't want to run the validating nodes myself, and I don't want to write the software to keep track of this. I'm going to go ahead and find somebody else that's done all this work. I'm going to find somebody else that is going to be able to run the nodes for me, and then with the PKI, there's going to be this built-in web of trust. So it's so we have the web of trust.
So essentially, what you are is you're the Ferrari of one-stop shops for people who want to go in, access your tools, your modularization tools. They don't need a lot of knowledge of blockchain, certainly don't need a PhD as Matt has, but they can access something that's not just a one-stop shop, but it's one of the best you're going to find so that they can actualize their intention to be more efficient, more scalable and more productive through your system. Is that the best way to explain it?
Exactly. So also another strength of the OneLedger is it have very clear of the structure and also very user-friendly API and SDK. Okay. So basically, and from the OneLedger, the architecture you can think about it layer by layer. So on the top, and the people build the module, and all the module and it could be REST by the REST service and REST API. So REST API is very popular the web technology in currently the world. So all these services of the module and created by OneLedger, it can be wrapped and calling from the REST API. Then under the REST API is the module level. Then under the module is the OneLedger blockchain access and the blockchain consensus. Then under the consensus, then you have the different sidechain to be parallel running with the main chain together. Then under the sidechain is all the main chain network with different public chain. Right. So between each level and each layer of the OneLedger, and we have the gateway, we have the good isolation to make sure that each transaction have the good security. As long as the people want to keep it go through, they can go through. But if someday they want to have the security can be isolated at different layer, this layer could have the good isolation.
I see. So clearly you've built in flexibility, and you've also designed, from my understanding, a hierarchy of protocols, which you're alluding to there, David. But if we could talk about now your value network, it's something important to you in your design. What essentially is this value network, and why is it a value?
So the value network, as I said, since we using so first of all, another strength of the OneLedger, which is the smart identity management system. So why we call it the smart identity management system, which means people can migrate their identity from public chain with a private key, with the PKI, the infrastructure, into the OneLedger level. So from a OneLedger, it manages the hierarchy of this identity from the different chain, using the smart identity system to manage the people identity. Also use this identity to trigger the different transaction across multiple different public chains.
I see. And that's a perfect segue into this very serious question of the SEC. Given that we're talking about ID, we're talking about compliance, we're talking about regulation right now, it's a buzzword everywhere around the world. What are your thoughts on that, both of you, with regard to ensuring that you are compliant, ensuring that you have those, those provisions in place to support more so the compliance and regulation of your?
Yeah, so yes, that's a good example, because the regulation, also the KYC, people need to know this is a personal identity, need to know and the credit. Right. But before and in currently system, currently world, and the identity is stay on the different chain, even if it's a people identity, but it's being separate. So we have no way to tracking, and we have no way to KYC based on people identity. Right. But it's a good example. We can use the OneLedger universal identity to do a KYC, to do the compliance with the regulation from the different country. Then meanwhile, once you have the universal identity, and think about it, you can use this identity to join the OneLedger into the different module to organize into the real society. Like you can join the social functionality, you can join your hobby, you can even watch a movie. All these different activity is a part of the OneLedger value network, is part of the OneLedger module. When you put all these modules together, when you put all the OneLedger module together with the universal personal identity, it's like a real society. And when people have this social and business functionality in this OneLedger society, it builds this OneLedger value network together.
I see. That sounds very well articulated in terms of the overall holistic nature. Matt, if we could talk now about you being the technical advisor, you would certainly know of the interface itself and the degree in which it's user-friendly. But can you talk us through a little bit more about the software design of it, and say from the consumer standpoint, how easy is it going to be to use OneLedger?
Right. So I mean, it really should be as easy as possible, and that's really the ultimate goal is to how do we onboard enterprises that aren't tech savvy or
right.
And I think that the way to do this is to have sort of a lot of developers incentivizations built in for developers so that they could write smart contracts, they can do all this stuff, and then have a marketplace that's available now to enterprises so that they can go ahead and pick and choose how they want to create their custom framework, or not just even be able to create their custom framework from the already built tools, but also go ahead and put out calls for proposals in a way so that you can have developers go ahead and build this for them and do it that way.
So it sounds like you have built in an incentivization scheme.
Yes, in part for the developers, as well as for node operators, for permission networks as well, and all that.
I see.
Yeah, so as we said, on the top level, if people in the business analyst side, they can build a module with the business functionality. So if they can build some just like a proposal into the OneLedger level. But if people like the coding or like write code line by line, they can directly write the OneLedger master smart contract.
I see.
You really do the coding level. That's why we really support the different perspective to join the OneLedger community, to join the OneLedger business world. And
also, David, what's great about your design is you are not language specific. You're not, from a developer's point of view, you are quite agnostic in that respect, and you're open to multiple different developing languages for designing smart contracts. Is that right?
So yeah, that's right. So since we're using a master smart contract, we use the modularization. Modularization is just like the object and the definition file, and also high level of the functionality. So on the bottom, you will have the ability to can convert or compile into the different language, like Solidity or like the C or any other blockchain language. But I mean, so what we're saying is we are not perfectly to transfer exactly into all the functionality into the different public chain to running. But at least we offer some like the template. Through a OneLedger, you can convert some of the template. On the top of it, you can build the public chain transaction functionality and the coding framework to deploy into the public chain.
I see.
And in this way, you can make this the OneLedger transaction and also master smart contract to be synchronized with the same functionality in the main chain and public chain.
I see. Well, thank you for that explanation. Matt, did you want to say anything there?
Yeah.
Yeah, I just kind of wanted to jump off of this master smart contract concept, and really what you have here is from a developer standpoint is a wrapper function. So if you have these different languages as you point out, what you can do is go ahead and actually write the various smart contracts in the multiple languages. The master smart contract can go ahead and identify which of the versions of the smart contracts in these other languages that you want to use and deploy on these various public chains. And so then the idea is you write the master smart contract as a wrapper. You go ahead and write the individual code in each of the languages that you want to use, and then with the help of the SDK, you can have some type of mechanism to help guide you in the process of converting from one version to the next. And then with the OneLedger protocol being able to deploy now on as many blockchains as the developer wants at the same time, and have that synchronization now across multiple ones.
And certainly, gentlemen, the potential there for appending to different blockchains is infinite, given that there's a multitude of, there's a wave of blockchains coming on the space, and you're not limited by any of them being, I guess, as we said before, for want of a better analogy, the glue that will bridge them together. But this is the exciting question, I suppose, for many people wanting to know more, is partnerships. Obviously, you have a great list of partners outlined already in your white paper, which is great. But I did want to talk to you about in the context of blockchains now, and more importantly, future enterprise partnerships and contracts you may be considering. So, David, this really has to go to you as the CEO. What's happening in 2018 as you build out your technology in the real world? What kind of partnerships are we talking about?
Yeah, I think since the beginning of the OneLedger, so we get a lot of support from the community, and we get a lot of people support for the partnership. So like the Polymath is a very successful the token security platform. So right now it's launching on Ethereum. So in future, once we launch the formal platform of the OneLedger, so Polymath, without any touch any the code, or without touch any the data integrity, they can migrate their existing platform into the OneLedger platform easily.
I see.
And yeah, same as the trust to pay. Trust to pay to try to build a social network to build the personal credibility to running the payment system. So think about when this kind of the personal identity and the credibility being separated in the different chain. It's really have no way to create the real credit system credibility, and we even couldn't create some of the universal credibility. But once they build it in the OneLedger, it supports the personal universal identity plus this kind of universal credit system attached to this personal identity.
I see. Thank you for explaining that, and no doubt you're planning on developing more partners. But let's talk about the real value, and that is obviously the smart contracts themselves, and with that comes a token system and no doubt a fee. So David, obviously we've discussed some key partners, you've disclosed some of them, and no doubt you'll have others in the future. But to really provide for a robust system, you need a fee-based system to ensure that you have revenue. So can you explain to us a little bit more about how the token system works that you have, and how the fee system will work for businesses as they move into the blockchains that you support?
Okay, so I think for the OneLedger in future, we try to build the big community. I'm starting from the beginning again.
That's okay.
Okay, yeah. So I think for OneLedger, and we try to give a good incentive to build the business network to get the more support from the community. And on the OneLedger in future, we plan to build the big developer community. On the developer, or either they could the developer themselves, or either could be enterprise the developer group. They can build the OneLedger module, and after they build the module, and when people use this module, they will do a subscription. And all this subscription is generated the revenue, and all the subscription fee will come to the developer or the business who build up this module. So once this business module running that transaction, and the OneLedger will collect the transaction fee, and this transaction fee will back to the community, and also this is the network maintainer who maintain all these transactions and the node. Like we said, we have the witness node. We witness all the transactions. So this node like the super node. So they will get this big revenue. It's come from the OneLedger level with all the transactions. So we build an ecosystem, and starting from the reward and the grant to a developer, and give them incentive to create the business module on OneLedger. When this generates more and more transactions, then we will maintain the big and the good ecosystem to maintain the good revenue on the OneLedger.
I see. So David, thank you for explaining that you're back mapping from the perspective of the consumer, or it's more to the point the developer, because you're going to try and incentivize them through the token. But I did want to ask you more specifically, if you're an enterprise and you want to utilize your service, is there any fee or is there any cost in transitioning? Because the reason I ask is that when you typically see a business appending to a blockchain right now, there's an inbuilt and implicit fee component via their own design. So is there any cost to an enterprise to jump on board with you?
So basically, we have this transaction fee to maintain this kind of the OneLedger consensus and the OneLedger network.
Mm-hmm.
So yeah, so whatever transaction that matter, it come from the personal public transaction, or it come from the partially the raw transaction.
Mm-hmm.
So all this part it will generate like a transaction fee.
I see.
And all this transaction fee will back to this like the who maintain this node. And also we try to build like the DPA, DPoS. So we try to build some like we call it the witness node. This node will be joining this DPoS to maintain the transaction and maintain the OneLedger network.
Okay. So Matt, if we could go now to, with your technical savvy, no doubt there are criticisms in the space, certainly of every blockchain design, and yours would not be, exempt from that. So, can you tell us about some of the criticisms or the challenges that you can already foresee?
Yeah, so there are a couple of challenges when it comes to the to PBFT, and probably the biggest one would be denial of service attacks. When it comes to knowing the in a permission scheme, if you have people who know the IP addresses, they could try to perform some type of denial of service. And so what ends up happening is that now you're going to end up with this maybe a consistent what's known as this leader view change. And so this view change, what you could have essentially a type of stalling on the network. And the way around this is, I mean, the original algorithm describes a mechanism where a priori sort of the way that the leaders would sort of change guards. So you have this changing of the guard, you know the order ahead of time. If you know the order ahead of time, that means you can go ahead and if you're an attacker, perform attacks in such a way that is going to be denial of service to this leader, then you're going to do a denial of service to this next leader, and so on and so forth.
Right.
So there are a couple of ways to mitigate this, and probably the biggest way is to make the order of the leaders that are participating in the validation process more random. So you would do something like using, say, randhound or randherd to do a secure multi-party computation in order to obtain some type of essentially a random number that allows you to create as a seed now to your pseudo random number generator to determine now an order now on the leaders and as they move through if there is this type of denial of service.
Right, and it's interesting you mentioned specifically about the multi third-party compute, and I want to broach this with you. I'm so glad you mentioned it. And that's because we've seen very recently OneChain has emerged from the darkness after many months, and they certainly are doing an interoperable interlinking sort of project as well.
I think that the advantages that OneLedger are really trying to go for is targeting enterprise solutions, as so doing this with this coupling of this public key infrastructure. Mm-hmm. By having that to allow for the permission networks, that allows for some really nice advantages.
Absolutely.
And so I think that from that perspective, there's a focus and a target of tackling different sets of problems than, say, some of these other projects.
Great, and perfect segue for David, because with challenges comes optimism, depending on the perspective. So clearly you're optimistic given that you have this permission component, David. But can you tell us a bit more about that? What makes you so excited about the future for what you can actually do?
Yeah, so I think as Masha just mentioned, so with when we build up the interoperability and about bottom, we build up the cross-chain transaction to support the multiple cross-chain transaction. Mm-hmm. And this part is not our target and the last intention. So we build the cross-chain transaction support is only for the enterprise leverage, mm-hmm. so that they can have the more scalability, and they can use kind of universal way to build up the enterprise leverage. So this is the target. Our target is to build the enterprise solution with the multiple chain transaction support.
I see. So obviously, for more people to know about it, you need access to the community. What kind of things are you doing to engage with the community, given that it is so premised on the digital space right now and the social space? How can people learn more?
So
they could go to your website, no doubt, but they could also go to Telegram, or they could go to Twitter.
Yeah.
What options have they got?
So okay, yeah. So regarding the community, so right now, and we have the white paper, and the white paper has the general information about the OneLedger and about the architecture of the OneLedger. And in future, we're also going to build the developer community and also the OneLedger community. And we are going to have the Twitter, we are going to have the Slack and a different channel to make the more people involved into the OneLedger together. So eventually, OneLedger, like I said, it's going to be like the virtual society. This society will include all the different people. People build the modularization together, and we make this modularization to be interactive together. Then people, all the people, be part of this community and also be rewarded by this community.
Absolutely. Well, gentlemen, thank you so much for your time today. I've learned personally a great deal about OneLedger that I didn't know before. Matt, is there anything you'd like to add, just as a final statement?
Yeah, I think that you brought up this issue before with the SEC, and David started talking about identity management. And one of the things that I thought was I was trying to sort of waiting for a chance to jump in. No, it's totally okay. But there's this there's the Euro region or the Eurozone. They have the right to be forgotten. This this law that they have, and this is potentially a problem for blockchains in the coming futures. Whenever we have this immutability, and if we don't have the ability of being able to remove data from the network. This could potentially be, like a very, something that people may or may not really recognize the extent that this could have. You could have personally identifying information on a blockchain. Now this could eventually, if it's never going to be able to be removed, well, what do you do? Now for whatever reason, potentially this blockchain could be completely banned in the Eurozone.
Right.
So
and Matt, just to add into there, perfect mentioning right now with regard to centralized models of data. Facebook is is in hot water right now for this same reason.
Right, exactly. And so I think that what you have with OneLedger is you have the ability with the public key infrastructure as well as with this whole notion of having a Byzantine fault tolerant solution with probability 1, where if you are trying to become forgotten, that could potentially be written into a protocol to allow for that to occur, and you could sort of mitigate those concerns sort of before they even happen. And I think that there's the ability of being able to do so, especially with the public key infrastructure and having this probability 1 consensus algorithm.
And I think also what's excellent is you've really illuminated the perfect synergies between the permissionless and the permission states of blockchain and the advantages of utilizing both. And also, very importantly, is really bringing to the fore the value of permissioned blockchains, because there's a strong perception, let's say, that permissioned blockchains are problematic or they're bad. They're bad for the system. What would you say to that, to someone who suggested that idea?
I think that you have to sort of weigh the situation closely at hand and really try to understand, well, why do you want permission schemes? And if you really want permission schemes, well, go ahead, and that doesn't mean that you can't have, it doesn't mean you have to throw out the baby with the bathwater, so to speak, right? You can actually have a lot of the advantages that you want when it comes to a type of, or at least a similar enough permissionless design, especially with OneLedger's public key infrastructure, because now enterprises can go in and they can say, all right, well, I may not know all these validators, and I may not know, and I may not even need to tell the validators who are the other people validating, so that you could actually, obfuscate that from a, from a hierarchical level. Say, all right, well, if I'm in control of this permission chain, right? Then I can go ahead and set the validators. The validators may not necessarily know the corresponding public identity on the OneLedger universal identity system, and what that allows you to do is you can still sort of remove that potential for collusion, but still obtain now the advantages of having a high throughput on the number of transactions per second with a permission scheme.
And Matt, just on a final point with regard to this very robust discussion, would you argue that given that there's a desire for institutions and for even governments to utilize the blockchain because of its efficiency and its scalability potential, would you argue that the imperative is actually to utilize it in this way, where you have to incorporate permission blockchains?
Yeah, I would think so, especially at a governmental level. I mean, it's not going to happen very fast, and especially when it comes to governmental bureaucracies. Right. But it's going to happen, and it's a question of to what extent you're going to have public trust, and how do you determine who are going to be the validating, nodes on these, say you're keeping track of real estate titles on a distributed ledger, so you don't have to go down to your local county courthouse and try to get the clerk to go ahead and search the records manually in some old paper database, essentially, right? Because that's what a lot of these places have now, is that nothing is digitized. It's all in some back room somewhere where you have to go through and sort of like comb through the records manually, look at the physical versions of them, as opposed to even having a database now. And I think that from a governmental perspective, even though you do obtain some level of redundancy with blockchains, with the distributed ledgers, the advantages that you have with that redundancy comes from the potential attack scenarios that you have with potentially terrorist organizations that would try to take out various sections of the government, either through physical means or digital attacks, and try to bring down those parts of the network. And so I think that the resiliency that you obtain with that redundancy with blockchain allows for you to mitigate those potential attacks.
Absolutely, and especially in terms of security as well. What I like is what you've said in a nutshell is you're trying to break down the bureaucracy with blockchain. So Matt, thanks for that really clear statement. So, what about you, David? If we could talk about your key sort of final statement that you'd like to address with OneLedger.
Yeah, so OneLedger, so just add on the top of what Matt just talking about, and very important is the OneLedger is give the high flexibility on the transaction, and for the privacy or the security, people can run some of the module, just run the transaction and the partial consensus internally. Then, but if they worry about someday if they are internally the damage being hacked or the data being lost, they can depend on some of the super node or the witness node from OneLedger level to witness all their data transaction or their partial transaction. Or even they want to have the consensus from the more public level. They can share part of their data to extend into the whole community and have the public transaction too. And that's why in this way, it has a high flexibility for the people to make choice and decide and what kind of data they want to share or what kind of data they want to manage.
I see. So you're trying to provide them unprecedented flexibility, access, and more importantly, scope with regard to your universal blockchain protocol design. So essentially, you are a Ferrari, as I said, a one-stop shop, a hub for all kinds of blockchains that are currently onboarding into the system that is to be the distributed ledger technology of the future. So on behalf of all the people who wanted to learn more about OneLedger, I would like to sincerely thank you, the CEO. Thank you very much, David Cow, for being on the channel today. Matt, thank you so much as well, Matt Niemerg. You are no doubt someone to watch in the future. I didn't realize just how well positioned you are with your credentials, but you are speaking the speak clearly. You are certainly partnering and connecting with OneLedger. That's an exciting and up-and-coming connection to really take note of. So OneLedger, thank you very much for your time, and we'll be watching you in 2018, 19, and hopefully the decade beyond to really watch you evolve in the space and become a serious player in what is to be arguably the transitioning of business models now into the future.
Thank you, Brad. And we have a very great time today. And hope in future we continue discussing about OneLedger and saw the growth of the OneLedger.
I would look forward to that. And thank you once again, Matt.
Thank you.
Wonderful. Thanks, Brad.